Welcome to this free course on Cloud Virtual Private Server Web Full Stack Deployment. Mastering this content will put you on the fast lane to becoming a highly sought after DevOps engineer. First, why should you learn this? The answer is very simple, because it pays. A quick Google search for average DevOps engineer salary in the US reveals an impressive almost $130K per year. Mastering cloud deployment is the quickest way for you to boost your market value. Second, you are going to elevate your practical knowledge. It's time to transition from being a localhost hero, where your apps work only on your local machine, but never see the light of the day, to becoming a highly versatile team member who knows exactly how to ship code to the cloud and thus make it available to the market. This free course is broken down into 3 concrete phases. In the first phase, I will give you the downloadable source code for a simple full-stack web application, the Wheel of Fortune game, with a Node.Js backend, a MariaDb database, and an HTML, CSS, and JavaScript frontend. I will explain quickly the implementation and show you how to run the code locally to understand the development. In the second phase, you will register with the cloud provider DigitalOcean, where you will get a $200 free credits for 60 days to practice. This is largely enough to master the course content for free. You will spin up a virtual private server and install our software stack. In the third and last phase, we will then configure the NginX web server to serve our static frontend and act as a reverse proxy for our backend API. Now, this deployment guide is completely for free. If you want to master the entire full-stack DevOps lifecycle, including architecture design with Arc42, C4 model, requirements engineering, DNS setup, securing your app with HTTPS and TLS certificates, and much more, you can grab my complete all-in-one full-stack DevOps Toolkit course on Udemy with the attached promotion link for just $10 instead of over $100. With that being said, let's get now for free your code running in the cloud. Let's begin with the code download and explanation.
Hi and welcome. Allow me to give you a high-level implementation overview of the finished full-stack web application. This allows you to safely skip the development sessions if you are already proficient in HTML, CSS, JavaScript, and Node.Js, and jump directly into the operations and deployment sessions. Alternatively, if you have implemented the code yourself, this serves as an excellent recap. Please go ahead and download and extract the zipped and attached resources file. I have already done so. Then open the root directory of the repository in your favorite integration development environment. I'm using Visual Studio Code. The code is structured in a npm mono repository, meaning that you have the backend, the frontend, and the documentation all in one repository. Let's begin our exploration with the frontend implementation. To be able to focus on the entire DevOps process, we keep it simple and implement a very simple full-stack web application, the Wheel of Fortune game. The entire frontend logic is contained in a single HTML file. Here we have in the body element the structure of the frontend. In the styles element we have the styling of the frontend, and in the script element we have the behavior of the frontend. Let's open the frontend in the browser. The behavior logic has 3 main responsibilities. The first responsibility is to fetch and display the current game state on each page refresh. The game state will be fetched via a REST API. The second functionality is to trigger the wheel spinning action via also a REST API. And the third functionality is to reset the game state also via a REST API. And as you can see, we have not yet started our backend. This is why we have not yet a connection. This is the front-end code. As next exploration step, let's check the documentation. In our requirements document, we have the functional and the non-functional requirements. Then we have our architecture documentation. For the architecture documentation, we used the Arc42 template combined with the C4 model. Crucially, the document explicitly defines the interface contract between the Node.js backend and the browser-based frontend. Let's check it. The backend will be running on the same machine as the frontend on the port 3000. This is a default port of Node.js, and we have our REST API running at /API. We have our data transfer object. This is a game state which contains the wins, the losses, and the last result. And we have 3 endpoints: one get endpoint to return the current game state, one post endpoint to spin the wheel, update the game state and set it in the database and returns the value. And we have the last endpoint to reset the game state to its initial values. And this API is implemented in our backend. The entry point of our backend is server.js. There we have the implementation of the 3 endpoints. If you look at the requirements, spinning the wheel means to randomly select one of these values based on the probabilities. And here we have the map. Those are the values and those are the probabilities. You can play around with it. The backend uses a repository pattern to enable a switchable data source. The choice between the file system or the MariaDb database is controlled via a DB type variable. To set the DB type, we just create an environment file at the same level at the package.json, and this environment file will be parsed using one dependency, the .env dependency. And here we have the list of the dependencies we need for the backend. For the repository implementation, we have a repository factory which loads the DB type variable. If the variable exists and it's MariaDb, then the database implementation is used, otherwise the file system implementation is used. And the 2 repository implementations implement the same interface, which consists of reading the game state, saving the game state, and resetting the game state. This is a database implementation, and the file system implementation implements the same interface and uses this file to manage the game state. Now let's go ahead and run the backend to be able to play the game. For this, open a terminal. And first we need to install the dependencies using npm install. You need to make sure that Node.Js is already installed on your system. This creates our node modules containing our dependencies. Then we can start the backend. Our entry point is server.js, which is in the backend folder. And now our backend is running, and as you can see, we have already created our file database with the initial value of the game state. And now we could go ahead and reload our frontend. Let's check what the problem is. Let's go to the network tab and reload. And here, as you can see, the frontend is trying to connect to our backend using a file path, which is not correct. Let's just fix it. We need only to fix it temporarily because we are not yet using a web server. After using a web server, the web server can translate this URI to localhost API. Now let's specify that we are using HTTP. And this will work, and we will fix it afterward to deploy it to a web server. Let's reload the front end. And now this is working. And when we play the game now, we can check the state in the file system. To use the database, we'll set the DB type to MariaDb later. Now we could reset the game state. And you could change the probability to lose 80% of the time and to win 20% of the time. And we need to restart our backend and reload this. Now this is working. And here you have a very simple full-stack web application with a web frontend, a Node.js backend, and a database. And we'll use this full-stack web application to deploy it to your local machine using a web server and to a cloud virtual private server.
Hi and welcome to this session on cloud deployment. As always, let's begin this session with a planning overview of the challenges to give you the opportunity to try to solve them by yourself, to prepare yourself to be a great software architect. In this session, we will deploy our application to the cloud, that is to a virtual private server, meaning just a machine on the internet. We'll use the cloud provider DigitalOcean. We'll first update our architecture documentation. We'll add an architecture decision record to explain why we choose the DigitalOcean as a VPS provider. Then we'll update our integration deployment diagram. The next step will be then to create a virtual private server instance with the operating system Ubuntu. There we will first register to the DigitalOcean and get free credits. We'll get $200 for the first 2 months. And this is enough to test our deployment. Then we'll connect to our DigitalOcean and create an Ubuntu instance. They call it Droplet.
The third step is to connect to the VPS instance using a secure shell. To do this, we'll first configure our SSH keys to be able to connect from our development virtual machine to the VPS instance. Then we'll connect to the VPS instance from our development machine and configure our firewall to open the ports for HTTP, HTTPS, and for SSH. After connecting to our VPS instance, we'll then install our software stack. We'll install Node.Js over the Node version manager. We'll install our database MariaDb and install NginX as a web server. The fourth step is then to check out our Wheel of Fortune GitHub repository. For this, we'll first create a GitHub personal access token. This will give us the permission to check out our repository in the VPS instance. Then we'll start the backend and test it locally. And the fifth step will be to configure NginX web server to statically serve our front-end files and to reverse proxy our backend calls. In this way, our application will be accessible over the internet. As last step, we'll then test our front-end from a remote machine, for example, our mobile device or our host machine. This is then our deployment stack. We have an Ubuntu instance running in the VPS provider machine on the internet, and we have there configured the NginX web server to serve our front-end and reverse proxy our backend and listen to HTTP and HTTPS ports. And when users try to access our front-end, this is configured and it will be served. And to start our backend and save our front-end to the deployment folder, we need to check out our code from GitHub. And this we'll do using a personal access token. Let's do this. Hi and welcome. What do you need to know about a virtual private server? A virtual private server, or VPS, is like a computer that you rent in the cloud. The hardware is managed by the VPS provider, the hosting provider. You get online root access to a virtual server over the internet. The more processing power and storage space you use, the more you pay. We'll use the VPS provider created 2011, DigitalOcean. We'll cover the reasons why later. What is a core developer workflow when using VPS? You first find a provider suiting your need. You create an instance. This is your private slot on the server. At DigitalOcean, it is called Droplet. Then you connect to this instance over SSH and you install your software stack. We'll use NginX as a web server, Node.Js as our runtime, and MariaDb as database. After installing your stack, you deploy your application. For example, we'll use GitHub to check out our repository and to serve our front-end and backend. We connect to the instance using SSH. SSH, or Secure Shell, is just a protocol to securely connect to your machines which run in the internet. And there we use key-based authentication. To authenticate to our machine, we'll need an SSH key pair. We create an SSH private and public key on the machine from where we want to connect to the server. This will be our development machine, our virtual machine. And we keep the private key on this machine. And we connect to our virtual private server instance. And there we put the public key. With this action, you are telling to your instance that anyone having the private key could access this instance. This we'll do hands-on using our DigitalOcean Droplet. This is a command. You need to create a private key. Then we'll copy the public key to our instance, and then we can connect the instance. After connecting, the developer is responsible for installing the software stack. We'll do this for our web application. Those are the commands to install MariaDb, for example, and a command to configure our firewall. The first step is to find the VPS provider which fits best our needs and budget. The decision drivers are cost effectiveness. It must fit our budget. In our case, it should be free. Then the developer focus. It should be very easy for developers to install their software stack. Then you need a good documentation for the installations, for the connection and so on, and a good community. And it should be easy to use, and it should have global reach and data centers. Depending on your needs, you need, for example, data centers which are in your country, for example.
And here we have a comparison of 4 popular VPS provider. We have DigitalOcean, we have Linode, we have Hostinger and Strato. And here you have the decision drivers. At DigitalOcean, you have a very low entry price. You get a free trial for the first 60 days for new users. And this gives us enough time to register and test our deployment without paying something. DigitalOcean was created for developers. It's very easy to install your software stack. The documentation is of best quality, and you have really good tutorials, and you have data centers worldwide, and it has a solid reputation about reliability. Your server is always online, and it just works out of the box. And here you have a comparison with the others. If you are in Germany and you need a server slot which is running in the European Union, this is a good choice. Hostinger has extremely cheap cost at the beginning, but the renewal is higher. This you should keep in mind. And Linode is a very good competitor for DigitalOcean, but DigitalOcean, as you can see, you have more credits for the begin, and it's better in 2025. That's why we will use DigitalOcean. In my browser search engine, I search for DigitalOcean new registration. This is a route. Here you can see that you will get $200 credits after registration. You could sign up with your Google account or GitHub account, or just create a new account. After creating an account and login, I found that I did not get any credits. This you can check at your billing. And normally when you get your credits, you see it here at credits applied. I contacted the support, creating a new ticket. They told me that I need to add a payment method to be eligible for free credits. This I can do now. I will use my PayPal account. Now I added a new payment method. We need to refresh this site. And after refreshing the site, you see that I have now $200 for 95 days. And this is largely enough for our deployment purposes. And you will have remaining credits to test other functionalities. When you use PayPal, they will add funds to your digital account from your PayPal account. Here you have $5. You will not use them. But if you do not want to do a prepayment, just use a Visa card. When you use Visa card instead of PayPal, they will just do an authentication request with $0 to your credit card. And then you will have also your $200 credits. And now we are connected here in our DigitalOcean account. We have our free trial activation, and we can create now droplets. This will be our virtual machine on the cloud. Let's do this in the next lesson. We have created a new account at DigitalOcean using this link. We signed in and got the free credits. When we log in, we see this free credit here. This is largely enough for our purposes. Now the next step is to create a droplet. Let's first mark this as done. And now we need to create an Ubuntu droplet. Let's do this. For this, we go to create. Then we create a new droplet. A droplet is just a virtual machine on the cloud. Let's click on it. And here you see the normal price, but because we have our $200, this should not be a problem. You can choose your region. I am in Germany, so I choose Frankfurt. The nearer the region is to you, the more performance you get from your virtual machine. And we choose here Ubuntu. We choose a long-term supported version. Let's choose our droplet type. The basic droplet is enough for us. We have just an example web app. We do not need a high performance CPU. The regular one is enough for us. And 4 GB RAM with 80 GB disk space is also enough for us. Let's go with this. We could also take less, but we take just this one because we will not pay for it.
It's very important after creating the instance when we no longer need it to remove the instance within our 2 months free trial. Otherwise, we will pay the usage of this instance. But I will show you how to do this. Let's choose first the password. So we set the root password. Afterward, we will set the SSH key pair manually so that you know how to do this. And here you can type in your password and remember it. After meeting the password requirements, you can create your droplet. You can select this because it's free. And we need to remember the password. You can display it if you want to be sure that you have the right password. Then we create the droplet. This can take some time. After creation, you see that our droplet is now active. This is the host name and this is the IP address of the droplet. And it's saved in our first project. We could have named this project, for example, Wheel of Fortune. And now we copy this. This is the IP address. Then we open a terminal and we use SSH. Then the username, we have our root user and the IP address of the droplet. I case this number. I will confirm this message with yes. And here I type in the root password I set earlier. And now I'm logged in into my droplet using SSH. Let's open our to-do list. We created an instance of our droplet and we checked the connection using SSH. Let's continue in the next lesson. Hi and welcome. After creating our cloud instance at DigitalOcean and testing the creation using our root username and password, the next step is to connect using a more secure way. This terminal is in our VirtualBox development virtual machine. And from here, we want to connect to our cloud instance without using a password. How we do this? We create a key pair, private and public key on this machine. And we copy our public key to the VPS instance. For this, we use the command line tool SSH keygen. We give the type of encryption and the key size. This will generate a private key in this folder and the public key also. I will use no password. Now a key pair is created here. Let's check this. We list the files in this directory. And here are the files. This is our private key and the .pub is our public key. The task is now to copy the content of this public key to our VPS instance. Copying the content of the public key to our VPS instance means that we have access to this instance and are eligible to configure this to be durable. That is, after doing this, we are telling our VPS instance, the machine having the private key for this public key can connect without a password. And to copy this file, we use the command line tool SSH copy ID. Then we use our connection to the VPS provider. We use root user. You could also create another user in your VPS instance and use it, but for simplicity reasons, we will use the root user and then the IP address of our VPS instance. Now we type in our password of the VPS instance. And here we see that one key has been added to our VPS instance. After adding the key, we can now connect using SSH without password. Here we are logged in without password. And we can check where the public key is. We change to the SSH folder. Then here you have a file called authorized keys. We can show the content. And here is the content of the file. This is the public key we copied. That is, we have created our key pair and we have connected to the VPS instance without password using the key pair. Let's skip the firewall configuration until we need it, and let's begin the installation of our software stack. We need Node.Js managed
with the Node version manager, let's go to our terminal, the terminal of our VPS instance, and check if Node is installed. Node is not installed. This is a repetition of the installation process we already did in our setup session. Let's do this very quickly. We open our browser and search for nvm and go to the official website. And here we have the wget command to download and install the Node version manager. We can close this terminal or just use the following command to reload our environment variables. To reload the shell. Now we can check the version of nvm. This version is installed, and let's install now the latest long-term supported version of Node.Js. Let's check the Node.js version. This version is now installed. We have installed our runtime to run our backend later, Node.js. Let's install as next step the web server NginX. In our development environment we use Apache. Let's use here NginX for the same purpose, to serve our front end and reverse proxy our backend. To do so, we open the terminal again. Let's update our package manager and let's install NginX. We confirm with yes. We check the status of NginX. With this command we use the service manager of Ubuntu to check the status of this command NginX. And we see it's running. We go out from here using Ctrl+C. We could stop the program using stop. It's now not active. Let's start this. Now it's running. Now NginX is installed in our VPS instance. The next step is to configure it to serve our frontend and to reverse proxy our backend. Let's change it to the default deployment folder of NginX. Let's create a file called Wheel of Fortune for our configuration. Let's open it with a text editor. And here we will create the configuration for our web server. Using Apache, we called the configuration block virtual host. Using NginX, we call it just a server block. Let's create a server block. Then we tell our web server to listen on port 80. Then we set the server name. This is the IP address of our VPS instance. Then we create a location block to serve our frontend. In one block, you always need to open it and to close it with the curly brace. And here we are configuring that when someone goes to this IP address and slash, we will serve our frontend, and we set the directory where we will put our frontend. This is a convention for NginX. You put your websites under this folder, and there we'll create a subfolder, Wheel of Fortune. We always end a configuration line with a semicolon. Now we tell NginX to serve our frontend from this directory from the file index.html. And now let's configure the proxy passing of our backend API. And our backend is running at /API. This is the mandatory line to forward calls coming to /API to our backend running locally at port 3000. Then let's go and search for proxy passing config to set some very recommended headers for NginX configuration. And we'll use this configuration to set those headers. It's highly recommended. That's it. This is our configuration. With this, we are listening at port 80, and incoming requests at the IP address / will get our front end, which we will save under this pass and index.html, and incoming requests at this IP address / API will be forwarded to our locally running backend. We use now the Ctrl and O to write this file, and we confirm with enter, and Ctrl and X to exit. Now we can check our content using cat. This is our NginX configuration. The formatting of the configuration is very important. So after configuring, we need to check if there are syntax errors. To do so, let's use the NginX command with the parameter t. And here we have that the syntax is okay. We have created our Wheel of Fortune NginX configuration, and we need to activate this configuration with the following command. With this command, we create a symbolic link in this folder with the sides enabled to activate our configuration. Now our NginX is configured. Let's create the deployment folder for our frontend in this folder. Yes, the folder does not yet exist, so let's create it using the makedir command. With p, we are creating all the subdirectories also. Now the folder is created. After checking out our code from GitHub, we will copy the content of the frontend to this folder. Let's check our to-do list. We have installed NginX and we have configured it to serve our frontend and reverse proxy our backend. Hi and welcome. After installing Node.Js and NginX, the next logical step is to check out our code and test our NginX configuration. For this, let's bypass the MariaDb configuration. We do this after the checkout. To be able to check out our code from GitHub, we need to authenticate. In our Git cheat sheet, we have a session on PAT. PAT stands for Personal Access Token. It is an authentication method which is much more secure than using passwords or external extensions. We used in our Visual Studio Code in our development machine the Visual Studio Code extension, but this extension we do not have in our virtual private server. So we use a PAT. PAT is much more secure than passwords or SSH keys. Why? Because you can configure very granular permissions. You can revoke or expire your authentication. You can auto-detect and revoke accidental commits because your credentials, you should not commit them on Git. And when you use a PAT token, it has a standard format, and many software tools can detect them when you try to commit them. It's very secure because the syntax is very unique. So to create a personal access token, we go to our GitHub and connect to our account and then create the token. For this, let's go to our virtual machine and open our GitHub account. Here we are connected to our GitHub, then we go to settings and then to developer settings. Then we open the personal access tokens and we create a classic one. And we use one for general use. And we create a classic one. It's enough for our purposes. I give it here the name for describing the purpose. I will call it a text integration access. And here I let it expire after 60 days. I give it full control, and this is the meaning of fine granular permissions. You could give it very fine-tuned permissions. Let's use full permissions for our purposes to keep this simple. And we generate the token. Then you should copy this token. It's very important. It will only be shown once. Afterward, you will not be able to access it. Let's save it temporarily here. And now we have a token, and we can use this token to connect to GitHub. And with this token, we can authenticate to GitHub from our VPS instance. Then let's go to our home and to our repository and copy the repo URL. And the command will be then git clone. Then we use this bad token and we paste it here, and we add an @ Let's copy now our git clone command and execute it in our VPS instance. You open a terminal and connect to the VPS instance. Let's check if Git is installed. Then we should create a workspace. Make dir workspace. It creates a workspace, then we change to it. And now we execute our command. Here we have our code. Let's display the content of the front end. And this is our front end. Let's display the content of the front end. And this is our front end. And now we need to copy our front end to our deployment folder. You remember the deployment folder is this folder is now empty, and we will copy our front end there. This is the deployment then of the front end. Use the copy command. Just copy the file index.html to this folder. Now the front end is there. And now we can try to run the backend. Let's change it to the backend folder. This is our backend with the code. And now we can just run the backend with the node command. And this will not work because we have not yet downloaded our dependencies, but let's try it. This is not working. Let's go one folder back. Here we are in the root folder of our repository, and here we have the package.json listing all the dependencies needed, but we have not yet the node modules folder. To create the node modules folder, we need to run npm install. When we list the content, now we have the node modules. Let's try to run now the backend. The backend is in the folder backend and server. Now our backend is running, and it uses the file system because we have not yet set the configuration file .env. There we could create the DB type and set it to MariaDb. But this is good. That is, our backend works. Let's open a new terminal and test our front end. In this terminal, we need to connect to our instance and then check that NginX is running. Is active and running, and not exit. I want it to clear. And here we could use the curl command to download a front-end file. We use this parameter to show us the headers. Then we use the IP address. And at / we want to serve our front end. Let's check this. And this is the NginX default website, meaning that this is not our front end. We need to open our own configuration. Let's use here the default pattern for single page applications. You can find this in the documentation. This means that on incoming requests at our IP / then a specific URI, The web server will try to serve the specific URI, then the folder at the specific URI, and then our index.html. And here in our root location, if you have the correct version, of course, you do not need to change anything. Let's save. You can just type in Ctrl X, and Nano will ask you if you want to change. We confirm this with yes, and enter. Let's reload our NginX configuration. This is reloaded. Let's try now to download our frontend. And this is the content of our frontend. And this is the same as port 80. Port 80 is a default port. That is, locally our frontend is served using NginX. And let's check if the backend is also correctly served using NginX. To do so, let's start our backend. The backend is started and running on port 3000. Now let's use a curl to make a REST call to the /API, omitting the port number. Let's execute a GET request using curl, as you may remember from our REST API lesson. We omit the port or set port 80, and we want to go to API. Here you see the response. That is, our backend is also successfully served by our web server NginX. And this is already working because we have not configured the firewall. Our firewall is not active. You can check this. It's inactive. So you can open a browser from your host machine. I will do this. Here I'm on my host machine, and I try to connect to our frontend at our VPS instance. And the game state is saved to the file system. The next step is to introduce a database. Let's check our to-do list. Checked out our code. We started the backend and the front end and tested it locally. This works. The last step is to install and configure MariaDb and to test the database. Hi and welcome. We are doing great cloud deployment progress. We have created a new account at DigitalOcean, the VPS provider. We got $200 credits. This is largely enough for us to deploy our application and test it. Then we connected to our Ubuntu VPS instance using SSH. First using the root credentials, username and password. Then we created SSH keys for passwordless connection. This is more secure. That is, now we do not need to type in our passwords. Then we installed our software stack, first installing the Node version manager, then installing the Node.Js runtime. Then we installed NginX as a web server. You see that it's running. Then we configured it. We created our Wheel of Fortune configuration. Now our NginX is listening at port 80. This is the IP address of our VPS instance. We configured NginX to serve our frontend, which we copied at this deployment folder. Incoming requests at the IP address / will serve our frontend, and we configured NginX to serve incoming request at /API to be forwarded to our backend running at port 3000. Then we checked out our code from GitHub. This is our repository. And to be able to check out our code, we created a private access token at GitHub. And this is our private access token. Now we can start our backend. Our backend is now running using the file system. We can access now our frontend using this IP address from outside the VPS provider. This is our frontend served by NginX. We can play. We can check that the backend is saving the game state to the file system. Let's make another connection.
And this is our file system database. Let's check its content. We see 2 wins, 0 losses, and $5,000. And this is what we see here. The next step is then to install a MariaDB database and to configure our backend to use it. In this way, we have deployed our full stack web application at our VPS instance. Let's do this. Installing MariaDB is very simple in Ubuntu. Let's first update our package manager. This is always best practice before you install new packages. Then let's install now MariaDB. We'll confirm this. MariaDB is now installed. Now we can connect to it using the command line tool MariaDB. And here we are connected to MariaDB with a default user root without password. This we will change later. And here we can show all the tables using show tables. Yes, first we need to create a database. Let's create our database. As you may remember, we are using the database called LuckyWheelDB. And as you may remember, this is a DDL, data definition language query from SQL. This creates a database called LuckyWheelDB. We got an OK, meaning that it worked. Now we can select this database. Now this database is selected. We can now show the tables. There are no tables. To signal that we are ready with the command, we write a semicolon. Now the database is selected, and now we want to create our table game state. And the SQL statement is the same as we used it in our previous lesson in the MariaDB database of our development machine. Now our statement is ready, and we end it using the semicolon. We are creating a table called GameState with a primary key ID, our 3 columns, wins, losses, and last result. This worked. Now we can show the tables again. We can show the structure of the table using describe. And this is a description of our table. Now our database is created with the table we need. We can exit this using the exit command. Now our database is created with the table we need. We can exit this using the exit command. Then let's change to our repository folder. As you may remember, we need to create our environment file, the .env. Let's create it using nano. And this file needs to be at the same level as our node modules to enable the .env package to parse it. And here we need this DB type variable. Then we exit using Ctrl X, confirm using Y, and enter. Now our end file is created with the DB type MariaDB. This means that when we restart our backend, it should use MariaDB instead of file system. Let's stop the backend using Ctrl C and restart it. And you see here MariaDB read game state. MariaDB is used now. And this error is very clear. The MariaDB installation is configured to not allow connection with root and no password. Let's fix this very quickly, and then we will set up the best practice. We will use a database user, which is not root. Let's first set a root password. Stop our backend. Let's connect to MariaDB. And now we will change the password of the user named root. For the connections from the local host, we'll set the password. This we do is the following DDL. And now we set a password. And this is very important. Let's copy this. And we'll now use the password in our environment file. This is now the password of our root user to connect at localhost. And now we need to apply the connections using the flash privileges. Now we can exit. And now we need to change our code to use the DB pass. Let's also now create a DB user. And here we load also our configuration values. Then we parse our DB user and DB password. It parses the configuration file. If the config value is not found, we use root as default. And for password, we use empty as default. And here, instead of user, we use the DB user. And instead of password, we use a variable. This variable is never used. Remove it. Let's commit this file. The environment file we do not commit. We set it in the deployment environment, there as a file or as environment variables. Let's commit our MariaDb repository. Stage it and commit and push it. The file is committed, and now we need to check out the change at our VPS instance using git pull. We see that one file has been changed, and now we need to set our configuration in the environment file. Copy this, Ctrl X to exit, yes, and enter. But in our development environment, we do not have a password for our root user. This is correct here. In our instance, it's with a password. Let's restart our backend. Our backend is running, and it will try to create a connection soon. And when it can create a connection, it does not throw an error message. Let's go now and access our backend. Now the front end is using the backend using MariaDb. We can now play. Save game state is called. Now we could connect to our database and check our table content. Let's do this. Now we changed the password of our root user. We need to set the password now. And we type in the password. I misspelled the password. Let's check this first. Texas secret. Now I'm connected. Can execute the select statement. Select all from game table. We first need to activate our database. Not game table, but game state. And we have the content here. Let's play again. And recheck. This is the content of our database. We can reset. Now the table is empty. We have successfully integrated our MariaDb connection, and our front end is reachable outside from the VPS. Let's update our to-do list. We have finished all our challenges for this setup. In the next session, we'll complete our full-stack web application deployment using our own domain name and SSL for secure connection. Hi and welcome. Let's do some quality checking before pushing our code to GitHub. We deployed our application to a local development environment, our Ubuntu virtual machine, and the VPS environment at DigitalOcean. This is done. The own domain name we'll do in the next session, and the security also. Let's check the changes. We updated our architecture documentation. We updated the component view of our deployment diagram, and we created a new network view for the deployment diagram, and we added the architecture decision record for our VPS provider choice. At requirements level, we mark the VPS and local deployment as done. Those are the diagram changes. This is a new diagram, network diagram, and this is our comparison table for the VPS provider. Let's commit this. First, we stage all changes. Then we commit and push this. One last thing we should do before completing the session is, for security reason, not to use a database root user. Instead, use a dedicated user for our application. We are connected to the database, and here we can create a new user. Call it Wheel of Fortune, and we restrict the access only from localhost, and we set its password. Then we give this user some privileges. We give all the privileges, but only for the database lucky wheel. All elements of this database. Here we set the username. We restrict those privileges only when the user connects from the localhost. Here we need the word to. Retry it. This worked, and we activate the changes. Now we can exit the database, stop our backend, and change the database username in our configuration. We no more use root, but Wheel of Fortune. Then we restart the backend. Backend is restarted. We play the game. Now we are using the newly created user. This is much more safe. The user has only privileges to one database and not to the whole system. Hi and welcome to the summary of our session on Cloud Virtual Private Server Deployment. We made tremendous progress in this session. We first documented our architecture decision record for the choice of our virtual private server. We compared DigitalOcean, Linode, Hostinger, and Strato, and decided to use DigitalOcean due to its free credits, a large community, and excellent documentation. Then we registered and received a $200 credit, which is more than enough for 2 months of free testing at DigitalOcean. Then we connected from our Ubuntu virtual machine, our development machine, to the VPS Ubuntu instance securely and without a password. There we used SSH keys. We checked then out the GitHub repository on the VPS, authenticated with a GitHub private access token for granular permissions, for expiration dates, and high entropy. Then we installed our Node version manager and used it to install Node.Js. Then we installed and configured NginX to serve our frontend and to reverse proxy our backend API. Then we installed and configured MariaDb. We created our database, our table, and a user, and set the privileges of this user to have only access to the database for security reasons. Then we tested external frontend access from the internet, ran the backend, and opened the browser on the host machine, and navigated to our frontend and played the game. And we recorded a summary of all this in our cheat sheet. With this, you have at least 20% knowledge to achieve 80% of VPS deployment tasks. Here we are connected in our development machine. This is our DigitalOcean account. Here we have our Ubuntu VPS instance. We connected to it over SSH. Now our backend is here running and using MariaDb. We tested the switch to use a file system with just one change in a configuration file. And we access now our frontend using the IP address, and we can play our Wheel of Fortune game. Congratulations on this great achievement. With this milestone, we have brought our full stack web application with a HTML, CSS, and JavaScript frontend, a Node.Js backend, and a database to the market.
and everyone can access it now over the internet.